What do we mean by functional groups? A functional group is an arrangement of atoms inside a molecule that has such strong and specific influence over the behavior of electrons that if a certain molecule contains this group, we can predict how it's likely to react. This means that we have a way to systematically organize and categorize the hundreds of billions of organic molecules that are out there by their functional group. We've already introduced one functional group, the halides. By virtue of their electron affinity and stability as a free anion in water, an alkane that has one of its hydrogens substituted for a halide, bromine for instance, is now more reactive and will react at the bromine in a similar way, whether the alkane is a 3-bromohexane, a 1-bromocyclohexane, or 3-bromo-4,5-dimethylheptane. The halides as a functional group can only really just be the one element, because halides are always terminal. Other elements or sets of atoms can have a similarly strong impact on the flow of electrons, and so the molecule's reactivity. After the halogens, the next natural element to look at is oxygen, because of its strong electronegativity and the two sets of lone pair electrons. Those will be attracted to positive charges, or positive areas on other molecules, which can then lead to the formation of new bonds. Chemical interactions and reactions that come to define the chemical properties of the entire molecule. We can just add a single bonded oxygen, but since that would have a formal charge of -1, it's really too reactive to be stable over time. So the oxygen in more common groups have two bonds and zero formal charge. One of the bonds is to carbon, the rest of the organic molecule that it's attached to, and the other bond changes how the oxygen behaves. Our simplest option is hydrogen. And whether it's methanol, which is toxic, or ethanol, which is less toxic, propanol, which is again kind of toxic, or isopropanol, a rubbing alcohol, an OH group or a hydroxyl group on a carbon structure is called an alcohol. That's the defining characteristics of alcohols. If instead the oxygen is bonded to another carbon chain, then we have an ether. Beginning in the late 1800s, diethyl ether was used as the original anesthetic agent for painless surgery. Before then, surgeons would just have to work quickly and hope their patients didn't die from shock. They still didn't know about bacteria, so their patients would still die from infection, but that's another story. The third common element that the oxygen can bond to is to another oxygen. This makes it a peroxide. The simplest is hydrogen peroxide, H2O2, but without any carbon bonds, that's not considered an organic molecule. Peroxides are way more reactive than alcohols or ethers. The oxygens are only loosely bound to each other and will very quickly react with other molecules to form bonds to carbons or hydrogens instead. This is why weak peroxide solutions are still really too strong to sterilize scrapes, why moderate solutions are actually too strong to bleach hair, and why high concentrations can be used to make explosives. So hydrogen, carbon, and another oxygen are the main contenders for what's going to bond to a single bonded oxygen. Now, double bonded oxygens are also very important in functional groups. So important, in fact, that they're going to get their own video. So we've moved down the row from the halides to oxygen, and between oxygen and carbon, we find nitrogen. Now, nitrogen is so stable as a gas that it's actually a bit tricky to get into organic molecules. That's why manure makes such a good fertilizer. It keeps nitrogen cycling through the system. And why ammonia synthesis was such an important development for global agriculture. Ammonia is kind of the prototypical nitrogen-containing molecule. But if we replace one of the hydrogens, we create a primary amine, like methylamine. Two organic substituents creates a secondary amine, like N-methylethylamine. A third replaced hydrogen, unsurprisingly I hope, makes a tertiary amine, like triethylamine. And honestly, that is one of the worst smelling things that just, no. Now that being said, it is one of the key scent molecules produced by Amorphophallus titanum, or the corpse flower, which blooms for one day every 7 years and produces a fragrance, honestly, that smells like a rotting corpse. And that, 10 out of 10, highly recommend, would smell again. Because nitrogen is such a stable gas, its rapid release through detonation can create a lot of explosive power. And that's why it's featured in a lot of substances that go bang, including the inorganic salt ammonium nitrate, in the nitro groups of trinitrotoluene, TNT, or 135-trinitro-135-triazanane, RDX, the main explosive militaries use in artillery shells or air-droppable bombs, and also in C4, or in the primary explosive lead stiffnate. Amines can also be combined with peroxide groups to get the very sensitive and very dangerous hexamethylene triperoxide diamine. And believe me when I say, if I had the choice between standing next to pounds of C4 or grams of HMTD, I would happily choose the C4, because those groups are way too functional for my taste.